Welcome to Part 5 of Section 1.1, Displaying Distributions with Graphs. In this segment, we're going to work with continuous variables. Continuous data cannot be put directly into frequency tables or displayed in histograms because continuous data do not have any obvious categories. So we must create these categories using classes or intervals of numbers. And there's no predefined categories. So we actually have to figure out what it will be, or make it. The continuous data is then grouped into these classes. Just as for discrete data, the classes and the number or proportion of values in each can be put into a table to form a frequency or relative frequency distribution, and a histogram can be created from the frequency or relative frequency distribution. So replace categories, qualitative data, or individual values, discrete quantitative data, with intervals of numbers, and we call those classes. Now, for discrete data with many different values, sometimes we have to use classes. So if our discrete data has many different values, we can start to treat it as if it were continuous, because we'd have too many bars in our histogram and too many classes. So we're going to look at an example where we are looking at discrete data, but the data values are so many that we have to put them into classes, because it makes it very easy to look at how we would make classes. So here we have adults 20 and older, and the natural way to do this is to go from 20 to 29, 30 to 39, 40 to 49, and so forth. And a little bit of definitions. 20, 30, 40, 50, and 60 are called the lower class limits for each of their classes. The 29, 39, 49, and 59 are called the upper class limits. And the 60 and older, well, that particular class is what we call an open-ended class. It's a class that has either no limit, no lower limit, or no upper limit. In this case, we're saying it has no upper limit. How do we determine the class width? Well, what we do is we take two consecutive classes and subtract them from each other. We take two consecutive lower limits, subtract it, and that will give us our class width. We could also do two consecutive upper class limits, subtract them, and that would be our class width. But we'll use the convention of always doing the lower limits. To find the midpoint, we would add the two lower limits and then divide by 2. And that's what this slide says. So we have raw data, and we find out that between 20 and 29 years of age, 533 in our sample were that age, 1,147 were between the ages of 30 and 39, etc. So we want to make sure when we do a frequency table, we select number of classes desired, choose the class width, choose class limits, count number of measurements per class, list the classes and frequencies or proportions or percentiles in the table. When you have frequency tables, there is no unique or best way of selecting classes, but the classes should not overlap, not have any gaps, have the same width, and cover the range of data. In other words, you want to make sure that every data point goes into one and only one place. Now, the lower class limits should be reasonable numbers. The class width should be a reasonable number. And typically, we want to use between 5 and 20 classes, with larger number of classes used with a larger data set. Select classes to provide a meaningful overall summary of the data. Too few classes cause data to bunch, and too many spread the data out so far it's hard to detect patterns. So we're looking at the distribution of 3-year rate of returns for small capitalization mutual funds. And if you see, the numbers 0, 2, 4, 6, 8, 10, 12, 14, and 16 are the lower class limits of their particular group. So when we see that bar that you see a 0 and a 2, that is, those are the stocks that gave a rate of return between 0 and 2, but not including 2, because 2 goes with the next bar on that histogram. So we could say 0 to 1.99 if that so works with the data, 2 to 3.99, and so forth. So when we construct a histogram, construct the frequency or relative frequency table as desired, place the variable of interest on the horizontal axis, and place the lower class limits for each interval on the axis. Draw a rectangle above each interval, and the height of each rectangle is proportional to the frequency or relative frequency for that class. And I hope you notice that the tick marks aren't at the midpoint, aren't in the middle, because this is a range of values. So we'll always have the tick marks at the cut points. So those tick marks at those cut points are the lower class limits of that particular class. Important points of histogram construction: plot and label only the lower class limits in between the bars. Provide a descriptive title, and as I said in Stat 250, it's going to be description of, you name the variable, for, and then describe the items. Label the horizontal axis, give the name of the variable and the units. Now remember, you must include those units. And label the vertical axis as for a bar graph, whether it is counts or percents, relative frequencies. So once again, we're going to get into the Minitab file. And again, you can get into it from course content or in the Minitab folder. So we look for data to make our histogram with. And I'm going to do the Minitab data for histograms, the Altria problem, and that's for our section. So we have our Minitab. The first thing we do is get into the sessions window and enable the commands. And what we're going to do is do a histogram. Now the slides that come next in your PowerPoints will give the commands that you would use. I'm going to show you by drop down. So you go to Graph, we want a histogram, Simple. There's our, hit OK, and what will come is a graph that would look like it's discrete, and this isn't correct because we know that this is continuous data, so we have to have our tick marks at the cut points, and we're going to learn how to do that. So what we're going to do is we're going to click onto the x-axis, and we want to go into binning, and what we want to do is we don't want our tick marks at the midpoints, we want them at the cut point, and then the number of intervals that we want. In this case, we have our stock goes from 3 to 11. So I'm going to go to number of intervals and make it 6. I'm going to hit the cut points, and then we could either change the number of intervals or create where we want our midpoint and cut points. And because I know something about the data, it's got a minimum of about 3 and a maximum of about 10. I mean of about 11. That means our whole range of data is 8. So I'm going to go on and do 8 intervals, and I'll explain why in a minute. But in here I'd say 8, and now I also want to put my positions of the tick marks at 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I have a nice graph of the stock. I changed the title. There's the good title there. And then daily stock volume in whatever it would be in millions. And we have a very good histogram. If I wanted to change this to a relative frequency histogram, I would touch my y-axis, and what type of graph, I would change it to percent and hit OK. A little bit different than our bar graph. And so now we have that, and you could add, just like we've been doing, we could add grid lines and all that good stuff. Yeah. And on the major tick marks. And there you have a really nice graph. That ends for part 5. We'll continue with doing graphs and histograms for continuous data. Thank you.